Alright, 3.3, the exponent laws. Now when we're looking at exponent laws, we're going to look at the different laws that you should know already. The exponent laws allow you to simplify expressions involving powers with the same base. And we're going to look at the different laws. The first one is the product rule. The product rule says if I have one power, a to the m, and I multiply it by another power, a to the n, as long as the bases are the same, I can do the following. Add the exponents. Keep the base and add the exponents. So one more time. If I have two powers multiplied and they have the same base, so two powers with the same base multiplied, what I can do is add the exponents. So keep the same base, don't change the base, and just add the exponents. So an example is 3 to the power 4 times 3 to the power 5. What do we do with that? Well, we have the same 3, so keep the 3. And what we're going to do is take 4 plus 5. And that gives us 3 to the power of 9. And that, folks, is known as the product rule. Quotient rule is the next one. The quotient rule says that I have a to the power of m divided by a to the power n. So again, two powers being divided with the same base. What we're going to do is, that's right, subtract the exponents. An example of this is 3 to the power 10 over 3 to the power 3. What will our result be? Well, we have 3 to the 10, 3 to the 3. That gives us 3, the base stays, to the power of 10 minus 3. What's 10 minus 3? That's right, I hope you're saying that 10 minus 3 is 7. So 3 to the power 7 gives us that final answer for that question. All right, one more. Power of a power rule. Power of a power. So we have a power raised to an exponent. So it looks like a power inside a power. So power of a power is what we result the name in. So a to the power of m, all raised to the power of n, means that we can now take our exponents, so again, keep the base, but multiply the exponents, m times n. An example of this is 2 to the power 3 to the power 2. What do we get as an answer? Well, we get 2 to the power 3 times 2. What's 3 times 2? That's right, I hope you're all saying that it is 2 to the power of 6. Okay, let's look at some examples to help clarify this. Here we go. Example. Simplify to a single exponent, then evaluate. So we're going to get a single exponent, one power, and then round the answer. So here we go. 2 to the power 3 over 2. 3 to the power 4 times 3 to the power of 3 divided by 3 to the power of 2 to the power of 3. C is 5 to the power 4 times 5 to the power 3. Divided by 5 to the power 3 times 5 to the power 2. Divided anyways, big long one over here. Let's look at the first example. 2 to the power 3 over 2. This 2 has an exponent. Hopefully you're thinking that the exponent on this 2, because we see 1 there must be a 1 here. And that's right, folks, there must be a 1. So it will be 2 to the power 3 minus 1. So expanding the exponent and collecting it like terms, the final result is going to be 2 to the power 3 minus 1, which is 2 to the power of, that's right, 2. And 2 to the power 2, you guys all know, is 4. All right, let's look at the next example. 3 to the power 4 times 3 to the power 3 over 3 to the power 2 to the power 3. So on the top, we're going to have 3 to the power of 4 plus 3, because it's the product rule. And on the bottom, it's the power of a power rule, which will be 3 to the power of 2 times 3, which will give you 3 to the 7 over 3 to the 6. Our final result is going to be, that's right, the magic number 3. Why is it 3? Because 3 to the 7 divided by 3 to the 6 is 3 to the power 7 minus 6 which results in 3 to the power of 1, which is just, that's right, 3. Okay, next one. Part C is tricky because there's multiple components, but if you do this carefully, it'll be quite easy. 5 to the power of 4 divided by 5 to the power of 3 times 5 to the 6. So we multiply these exponents. Divide on the bottom by 5 to the power of 4 times 5, and we do 5 to the power times 5, but this is a number we still count. So we have 5 to the 4, 5 to the 3, times 5 to the 6. So 4 minus 3, and then you add 6. What's the result in the numerator? That's right, 5 to the 4 minus 3 plus 6 is going to give us 7. On the bottom, it's 5 to the power of 4 plus 1. 4 plus 1 on the bottom. So on the top, you have 5 to the power of 7. On the bottom, 5 to the power of 5, which results in 5 to the 2. Let's go back. 5 to the 2, because 5 to the 7 divided by 5 to the 5 is 5 to the 2. 5 to the 2 equals our final result. 25 is our final result. Okay, one more page, folks. Here we go. Example number 2, simplify. So here's a bunch of different problems with different variables, and we have to combine all the like terms together. So in this case, like terms when we're doing it is not adding or subtracting, but what we're doing is taking the numbers and multiplying them. That gives us our 30 meters squared n times 2. Okay, so what happened here, instead of multiplying, what we did was we expanded it first. So we took this exponent and multiplied to put that exponent to everything inside here. So we give it to 2, we give it to the m, we give it to the n. This can only happen, folks, in multiplication or division. Definitely not in addition or subtraction. No, 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 folks. So 30 m squared n times 2 to the power of 2, m to the power of 2, n to the power of 2 will result in 4 times m squared times n squared, all over 5mn squared plus 6mn. Now, what do we do now? Well, we're going to put the numbers in the numerator together. So you get 120, and then we put the m's together, which gives us m to the... Okay, just a moment. Let's just check. M to the 3, or is that 4? It turns out, folks, it was a 4. So again, 30 times 4 is 120. M squared times m squared is m to the power of 4. N times n squared is n cubed. On the bottom, 5 times 6 gives us 30. M times m gives us m squared. And n squared times n gives us n cubed. Now we can simplify this expression. So we would get 120 over 30, which is 40. Sorry, 4, not 40, but 4 m squared n. Why is it m squared n? M squared, sorry, and no n. The reason we have no n is we canceled it out over here. There are 3n cubes. With 3n cubes, they disappear, so we're only left with m squared. Okay, let's look at part B. Part B says it's a bunch of different things. Let's get rid of the power part first. So 27 x cubed y to the power 6 times negative 4x squared y over 2 to the power 2, which is 4, x to the power 4, y to the power 4. All right, we've done this. Now what we need to do is simplify. So in the numerator, we get 27 times negative 4, which is negative 108, x to the power 5, and y to the power 7, over 4, x to the power 4, y to the power 8. Sorry, 4. That's a mistake there. It's y to the power 4. Now, what we're doing is, we have all of these values, we substitute. Negative 108 divided by 4 is negative 27. X to the 5 over x to the 4 gives us x. Y to the 7 over y to the power 4 gives us y to the power 3. All right, well, that's the end of the examples, folks. Have a numerical day.